Hello everyone. Today we are going to discuss about the BEEE Lab viva questions for the part A experiments. In the part A experiments, we have the verification of KCL, KVL, and the Thevenin's theorem, Norton's theorem, and the reciprocity theorem, superposition theorem, and maximum power transfer theorem. For these questions, we will discuss what are the viva questions we are having. Okay, with solution we will discuss. Then in this first one is, what is the statement of KVL, Kirchhoff's voltage law statement? If you see the statement of the KVL, Kirchhoff's voltage law, this law is also called as Kirchhoff's second law. It states that the algebraic sum of all the voltages around any closed path or any closed loop is always equal to 0. That is, sum of all the voltages in a circuit is equal to 0. Suppose assume that if there are 3 voltages in the circuit, so algebraic sum of all the voltages, that is V1 minus V2 minus V3 is equal to 0. So like this we will get, here the supply voltage is V1 and the remaining voltages are V2 and V3, voltage drops. So V1 minus V2 minus algebraic sum of all the voltages in a circuit is equal to 0. So like this we will get. Next, what is the statement of KCL, Kirchhoff's current law? If you see the statement of KCL, Kirchhoff's current law states that the current flowing into the any node or junction must be equal to the current flowing out of the node. Okay, entering currents is equal to the leaving current. That is called as a KCL, Kirchhoff's current law. Suppose if we assume that this is a node, it is a I1 current is entering and I2 current is also entering and the I3 current is leaving and I4 current is also leaving. According to the KCL, we can write that some of the entering currents are I1 plus I2, two currents are entering, and the leaving currents are I3 and I4. So sum of the entering currents is equal to sum of the leaving currents. This Kirchhoff's current law, we can also call it as Kirchhoff's first law. Okay, next, KCL is based on the which principle? KCL is based on the law of conservation of charge. Okay, based on this principle, it is based on the conservation of electrical charge. Okay, next, KVL is based on which principle? KVL is based on the law of conservation of energy. It is based on the law of conservation of energy. KCL is law of conservation of charge. Next one, what is the statement of Ohm's law? Ohm's law states that the current I is directly proportional to the applied voltage V, provided temperature and all other factors remains constant. Mathematically, we can write it as V is equal to I into R, or I is equal to V by R, or R is equal to V by I. This Ohm's law, we can write it in this formula. This Ohm's law is used to find out the unknown parameter. That is, if you know the I and R, we can find out the voltage by using this formula. If you know V and R, we can find out I by using this formula. If you know V and I, if to find out R, we will use this formula. Okay, this is about the simple Ohm's law statement. Define linear elements with examples. A circuit or the network whose parameters or LC of the resistance, inductance, and capacitance are always constant, irrespective of the change in time, voltage, and temperature, is known as linear circuit. The Ohm's law can be applied to such circuit. In this, the inductance, capacitance, and the capacitance are always constant, even if you change the voltage, current, and the temperature. Then that circuit is called as a linear circuit. The examples of the linear elements are resistor, inductor, and the capacitors are called as linear elements. Next, non-linear elements. A circuit whose parameters change their values with a change in time, temperature, voltage is known as non-linear elements. Ohm's law is not applicable for such circuit. In the non-linear element, this is exactly opposite to the linear elements. So if you change the voltage, current, and the temperature, the properties or the parameters will change. Okay, so the examples of this non-linear elements, we can take it as a diode is also one of the non-linear element, and the BJT, that is a transistor, is also one of the non-linear element. If you change the supply voltage, if you reverse the terminals, then the characteristics will change. If you change the voltage or if you change the temperature, the characteristics of these parameters will change. Okay, these are the two examples. We may have the many examples. What are the limitations of Ohm's law? Ohm's law is also not applicable for non-linear elements. Ohm's law is not applicable for non-linear elements. Okay, it is applicable for only linear elements only. This is one of the limitation of Ohm's law. This law cannot be applied to unilateral elements. Okay, we will discuss what is unilateral and bilateral, but it is not applicable for unilateral network. A unilateral network has a unilateral elements like diodes and transistors, etc., which do not have same voltage or current relation for both the directions for current. Okay, these are the examples. Diode and the transistor are the examples of unilateral elements. Okay, so for the unilateral elements, Ohm's law is not applicable. That's why these are the limitations of Ohm's law. Ohm's law we cannot apply it for these unilateral elements and the nonlinear elements. What is voltage division rule? The voltage division rule states that the voltage divided between two series resistors are indirectly proportional to their resistances is called as the voltage division rule. This voltage division rule is used to find out this voltage drops across each and every resistor. Suppose assume that there are 3 resistors. It is a total voltage V. Assume that it is R1 and it is R2. It is V1. It is V2. Okay, by using this voltage division rule, we can find out the voltage drops V1 and V2. Here, if we take V1 is equal to total voltage is V and the same resistance R1 divided by R1 plus R2. And similarly, if you want to find out V2 value, total voltage V is equal to same resistance by sum of the resistance. So like this, we will use the voltage division rule. This voltage division rule states that the voltage divided between the two series resistors are indirectly proportional to their resistance. Okay, here this is for two resistors. We can also take, there are many resistors connected in series. Next, what is current division rule? A parallel circuit acts as a current divider as it divides the total circuit currents in all its branches. Okay, this is in parallel circuit current divide. The dividing current we can find out by using this law. Okay, now we will take one sample circuit which is having, there are 2 resistors connected in parallel. Assume that it is R1 and R2. It is a supply voltage is V. Assume that it is a total current I, and I1 is a current passing through the R1 and the I2 is a current passing through the R2. This I current is divided into 2 parts as there are 2 resistors I1 and I2. We need to find out dividing currents by using current division rule. So current division rule states that here the required current, I am finding I1, required current I1 is equal to total current into opposite resistance. The current passing through the I1 is current passing through the R1 is I1. So for this R1, the opposite resistance is R2. Opposite resistance R2 divided by sum of the resistors R1 plus R2. So I1 we will find out by using this formula, that is a current division rule formula. Now we need to find out I2 value. Current passing through this resistor. For this resistor, opposite resistor is R1. So for that, total current is I and the opposite resistance is R1 divided by R1 plus R2. Okay, these are the formulas by using the current division rule. We can find out the dividing currents by using this current division rule. Next one is, what is mesh analysis? Mesh analysis is used to find out the loop currents in the meshes, which is written in terms of the voltage I into R form. Total voltage gain in the loop is equal to total voltage drop in that loop. Okay, this mesh analysis is based on the KVL plus Ohm's law. Okay, by using this, we can find out the mesh currents. If you know the mesh currents, we can find out the voltage across each and every resistor. Now, what is nodal analysis? Nodal analysis is used to find out the node voltages in the circuit, which is written in terms of I is equal to V by R form. Total current entering into the node is equal to total currents leaving that node. Okay, in the nodal analysis, we use KCL plus Ohm's law. This KCL is used to find out the node voltages. If you know the node voltages, we can find out the current passing through the each and every resistor. This is about the mesh analysis and nodal analysis. Now we'll see what is the statement of the reciprocity theorem. In any linear bilateral network consists of energy sources and resistors, then the response is same before interchanging the source and after interchanging the source. If we take the circuit, this is the reciprocity theorem circuit, which is having the three resistors. This is the source and it is a load. Now if we interchange the source from here to here, we will get the circuit like this. So according to the reciprocity theorem, before interchanging the source, the response is Ix. Ix must be equal to, after interchanging the source, the response is Iy. So from this we can say that before interchanging the source and after interchanging the source, the response, that is Ix and Iy, both should be equal according to the reciprocity theorem. This is a reciprocity theorem statement. Next, what is the statement of superposition theorem? It states that in any linear bilateral circuit having more than one independent sources and resistors, then the response in any one of the branch is equal to the algebraic sum of the responses caused by individual sources, while the rest of the sources are replaced by its internal resistance. See here, this is the circuit diagram of the superposition theorem. This is the given circuit. When both the sources are present, the response we are taking in the middle resistor, that response is Ix. And when V1 is present and V2 is equal to 0, in this case, we are taking the response is Iy. Plus, when V2 is present and V1 is equal to 0, in this case, we are taking the response across this R3 resistor is Iz. The response in any branch, this response is equal to algebraic sum of responses caused by each source acting alone. In this circuit, V1 is present, in this source, V2 is alone. So according to the reciprocity theorem, Ix should be equal to Iy plus Iz. This is the superposition theorem statement. Next one. What is the statement of maximum power transfer theorem? It states that in any linear bilateral circuit having the energy sources and the resistors, then the maximum power will transfer from source to the load when load resistance is equal to the source resistance. Here, this is the given circuit. For this circuit here, the maximum power transfer from source to the load, the maximum power, this is the source equivalent voltage source, that is a VTH, and the equivalent resistance RTH, and it is a load resistance. The maximum power will transfer from, this is a source and it is a load, source to the load when RL is equal to the RTH. Here, when load resistance RL is equal to the RTH, the maximum power will transfer from source to the load. Okay, this is the maximum power transfer theorem. To find the maximum power transfer theorem, first we need to find out the Thevenin's equivalent voltage and the Thevenin's equivalent resistance. After that, when these both are equal, then the maximum power will transfer. Next, what is the statement of Thevenin's theorem? It states that in any linear bilateral complex network having more number of elements, the entire network can be replaced with an equivalent circuit called as a Thevenin's equivalent circuit, which is consist of Thevenin's equivalent voltage source VTH in series with the Thevenin's equivalent resistance RTH. Here the total circuit can be, this is the given circuit which is having, there are three resistors and the RL is a load resistance, VS is a supply voltage. This total circuit can be replaced with equivalent voltage source VTH that is connected in series with RTH and RL is a load resistance. This equivalent circuit we will find out by using this Thevenin's theorem. This is the given circuit and this is the Thevenin's equivalent circuit. This total network can be converted into simple network. Okay, next one is a Norton's theorem statement. It states that in any linear bilateral complex network having more number of elements, the entire network can be replaced with an equivalent circuit called as a Norton's equivalent circuit, which is consist of Norton's equivalent current IN in parallel with the Norton's equivalent resistance RN. Here, this is the given total circuit, okay, which is having, there are three resistors and one load resistance and the supply voltage. This total circuit can be replaced with an equivalent current source that is called as a Norton's equivalent current that is connected in parallel with Norton's equivalent resistance, and RL is a load resistance. By using the Norton's theorem, we will find out that complex network we will convert it into simple network. Next one is define unilateral network with example. A circuit use operation and the behavior is dependent on the direction of the current through various elements is called as a unilateral element. Okay, here the examples of unilateral elements are diode and a transistor, that is BJT. These are the unilateral elements. Suppose if you change the direction of the supply, the behavior will change. For example, if you take the diode here, for the diode here, positive terminal is connected to P and the negative terminal is connected to N. Then we can say that diode will be in the forward bias condition. Suppose if you change the directions of the supply here, suppose if you change the directions here, minus plus P terminal and the N terminal. Okay, here negative is connected to P now and the positive is connected to N. Then we can say that the diode will be in the reverse bias condition. Okay. If you change the direction, the behavior of the diode is changing from forward bias to reverse bias. Then we can say that it is a unilateral circuit. Okay, next we'll discuss about the what is bilateral network. A circuit whose characteristics or the behavior is same irrespective of the direction of the current through various elements of it. And it is called as, then it is called as a bilateral element. In bilateral element, the examples are the resistor, inductor and the capacitor. These are the examples of the bilateral elements. Suppose if you take the resistor here, if you take the resistor, assume that here I current is flowing, V is supplying here 2 ohms and it is a 2 ohms of the resistor. Now if we calculate the I value, I is equal to, what is the formula? V by R. V is equal to 10 and R is equal to 2. We are getting 5 amperes. Suppose if we take the terminals are reversed, if we take the terminals are reversed, it is a 10 volts. The direction of the current will change, but not the value. 10 by 2 is equal to 5 amperes only. Okay, here from the bilateral network we can say that it is 2 amperes. Suppose if it is, the terminals are like this, the current is flowing in this direction, that is 5 amperes of current is flowing. If you interchange the terminal, the same current is flowing but in opposite direction. Okay, but there is no change in the value. That's why in bilateral network, the behavior or the characteristics will not change, same. What is the condition for maximum power transfer theorem? In the maximum power transfer theorem, when load resistance is equal to source resistance, then we can say that maximum power will transfer. The maximum power we will find out by using this formula, VTH whole square divided by 4 into RTH. VTH is nothing but Thevenin's voltage and the RTH is nothing but Thevenin's resistance. Next one is define active and passive elements. Active elements in which can produce the or gives the energy in the form of voltage or the current is called as the active elements. These are also called as the energy donors. The examples of the active elements are voltage source and the current source are the examples of the active elements. Next, passive elements in which can take the energy in the form of voltage or current are called as the passive elements. These are all also called as a energy donor, energy acceptors. So the examples of the passive elements are resistor, inductor, and capacitors are the which can take the energy. That's why it is called as a passive elements. Here the voltage source and the current source, these are the gives the energy, and we can also take the battery. Okay, these are gives the energy in the form of voltage or current. That's why these are all called as active elements and these are the passive elements. Next, what is independent and the dependent sources? Dependent sources is a voltage source or the current source whose value of the source depends on the voltage or current in the circuit. There are 4 dependent sources are there: voltage dependent voltage source and the current dependent voltage source and the voltage dependent current source and the current dependent current source. In the voltage dependent voltage source, this voltage source depends on the voltage, and in this voltage source depends on the current. In this, the current sources depends on the voltage, and in this, the current source depends on the currents. So these are the dependent source, and these are the examples. If you see the independent voltage source, if you see, independent sources are of 2 types: independent voltage source and independent current source. The independent source is the supply a constant voltage and that does not depends on any other quantity like voltage and current within the circuit. Next, independent current source supplies a constant current and that does not depend on any other quantity like voltage and current within the circuit. Which depends on the other element is called as a dependent source, which does not depend on the any other circuit is called as independent sources. So independent voltage source we will represent like this. Inside the circle there is a plus and minus, that is called as independent voltage source, and inside the circle if it is arrow symbol, that is called as a independent current source. This dependent source we will indicate in the rhombus symbol. This is the rhombus symbol. For example, we will take one example here: voltage dependent current source. First of all, it is a current source, that's why inside the rhombus take the arrow symbol. It is depending on the voltage, that's why Vx. We are taking this one, and the remaining we have to indicate like this only. Next, what is source transformation technique? Source transformation means simply replacing one source by an equivalent source. That is, a practical voltage source can be transferred into the equivalent practical current source, and similarly a practical current source into the practical voltage source. Here, suppose if we have the this is the voltage source we are having. Okay, this voltage source value is, it is a 10 volts and is a R is a 2 ohms. This, if we convert into practical current source, the practical current source will be one current source that is connected in parallel with the resistor. This is the practical current source. Here, from here to here, there is no change in the resistor value. If we want to find out the current source value, I is equal to, the formula is V by R. V is equal to 10 and R is equal to 2. If we calculate this, we will get 5 amperes. So this is the voltage source to current source. If we want to find out the current source to voltage source, the same formula, V is equal to I into R, to find out the voltage source we will use. This is about the source transformation technique. converting one source to other source is called as a source transformation technique. In this example, we have converted voltage source to the current source. Next, what is series and parallel circuit? A series circuit is one which two or more resistors are connected one after other. Such connection is called as an end-to-end connection or the cascade connection. There is only one path to flow the electron. If you see here there are two or more resistors. Three resistors are connected one end to end. Three resistors are connected end to end or in a cascade connection. Here current is same in the circuit, but the voltage divides. V1, V2, V3 are divides in the circuit, but there is only one path. This is only one path to flow the current. That's why it is called as a series circuit. When the resistors are connected in series, the formula is R is equal to R1 plus R2 plus R3. As there are three resistors are there, we are taking the three resistors. That's why R is equal to R1 plus R2 plus R3. In the parallel circuit, in which the resistors are connected such that one after other or one over other is called as a parallel circuit. So this is a parallel connection. In the parallel connection, here resistors are connected one after other. In this, the voltage is same, but the current divides across the each and every resistor. Okay, according to the parallel circuit, here the formula for the resistor is 1 by R is equal to, we will get 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula to find out the when two or more resistors are connected in parallel. Next one, what is resistor? A resistor is an electrical component that limits or regulates the flow of electrical current in an electrical circuit, electrical or electronic circuit, whatever it is. Okay, this resistor is symbol is, this is a resistor symbol, and the units of the resistor is ohms. Ohms are the units of the resistor. Next one is, what is inductor? An inductor is a passive electronic component that temporarily stores energy in a magnetic field when the electric current flows through the inductor coil. Which stores energy in the form of magnetic field is called as an inductor. This is the inductor symbol. It is denoted by L, and the units of the inductor is Henry. Next one is, what is capacitor? A capacitor is a two-terminal electrical device that can store the energy in the form of electric charge. It stores energy in the form of magnetic field. It stores energy in the form of electric charge. Okay, this capacitor, this is the capacitor symbol. It is denoted by the letter C, and the units are farad. Okay, this is about the resistor, inductor, and capacitor. They will ask the basic definitions. Next, what is current? Current is a flow of electrical charge carriers like electrons. Okay, the units of current is ampere. Simply A. Current is the flow of electrical charge carriers like electrons. Flow of electron is called as a current. Okay, the units of current is amperes. The current is denoted by small I or capital I. Next, what is voltage? The voltage is defined as the electric potential difference per unit charge between the 2 points in an electric field. That is, voltage is expressed mathematically using the symbol capital V or E. Okay, the units of voltage is volts. Simply, we will take it V. Next, what is power? The power is the rate of energy supplied or consumed by an electric element with respect to the time. The power of a circuit element is a product of voltage across the element and the current passing through it. So we can also indicate power is equal to voltage into current. Product of voltage and current is called as power, and the units are watts. Okay, this is about the current, voltage, and the power. Next, ideal and practical circuit. What is ideal voltage source? We will discuss first. A voltage source is a two-terminal device whose voltage at any instant of time is constant and is independent of the current drawn from it. Such a voltage source is called as an ideal voltage source, and it has a zero internal resistance. Practically, an ideal voltage source cannot be obtained. Next to practical voltage source. Before that, we will draw the ideal voltage source. Okay, this is called as a simple ideal voltage source. Okay, here there is no internal resistance here. Now, if we take the practical voltage source, the voltage source is having some amount of internal resistance are known as a practical voltage source. Due to this, the internal resistance, there is a voltage drop takes place and it causes the internal, that is the terminal voltage to reduce here. Here, if we take the practical voltage source here, in the practical voltage source, there is a voltage source that is connected in series with the resistor. Because of this resistor, there is a voltage drop here. If we draw the characteristics here, if we take the here, see the practical voltage source here, there is a change in the current, but here the voltage, there is a slight decrease in the voltage here. Instead of getting this constant, okay, there is a voltage drop because of this internal resistance. But in case of this here, it is the current versus voltage. Here the voltage is constant, irrespective of the change in the current. Okay, the voltage is constant here. But here, if you change the current here continuously, there is a slight drop of the voltage because of this resistance. That's why it is called as a practical voltage source. In practical voltage source, there is a drop of the voltage. In the ideal voltage source, there is no drop. Now, if we discuss the ideal current source, okay, an ideal current source is a two-terminal circuit element which supplies the same current to any load resistor connected across its terminals. It is important to keep it in mind that the current supplied by the current source is independent of the voltage source terminals. Here in ideal current source, okay, now before going to the practical current source, we will draw the ideal current source here. An ideal current source is the simple ideal source. It is not having any internal resistance here. If we draw the diagram here, it is a voltage versus current. In this, if you change the voltage continuously, here there is no change in the current here. We will get the constant characteristics. But in case of the practical characteristics, a practical current source is represented as an ideal current source that is connected with the resistance in parallel. With this, current drop takes place. The symbolic representation as shown in below. Here, in the practical current source, one internal resistance that is connected in parallel with the current source. It is R and I. It is a resistance connected in parallel with the current source. Here it is a voltage and it is a current. Instead of getting this line, if you change the voltage continuously, there is a drop in the current source. This drop is because of this internal resistance. That's why it is called as a practical current source. In ideal current source, there is no current drop, but in the practical current source, there is a drop in the current. Next, what is circuit? A circuit is a path or the line through which an electric current flows. And the electric circuit is a combination of active elements and the passive elements. Next one is what is node. So now we will draw one small circuit here. This is one of the circuit. Assume that it is V1 and V2, R1, R2, R3. So simply we can say that the circuit is a combination of active elements and the passive elements, which is having a closed path. Here, V1, V2 are the active elements, voltage sources, R1, R2, R3 are the passive elements. Circuit is a combination of active and passive elements. Electrical circuit is a path or line through which the electric current flows. So in this, the current flows as it is a closed path, and electric circuit is a combination of active and passive elements. These are the active elements and the passive elements. This is simply, it is a circuit. You can take any one of the circuit, but this is a one of the circuit. Next one, we will define what is node. So this is the one random circuit we have taken. A node is a point where two or more branches are connected together. So this is the one branch and this is the one branch. This is the one more branch. All the branches are connected at this node. Okay. Next one is, what is branch? A branch is generally two terminal elements such as voltage or current source or the resistor or the inductors. Okay. Here in this branch is a combination of any one of the element here. In between the two terminals, in between these two terminals, here there is a resistor element. In these two terminals, there is a one more resistor. In these two terminals, there is a one more resistor. In these two terminals, there is a voltage source. This is the one branch. Okay, this is also branch, and this is also branch. This is also one branch, and this is also one branch. Branch is generally a two terminal element. Two terminal element. In between two terminal, there is a element. That's why it is called as a branch. Okay, node is called as, it is a two or more branches are meeting at one point. That is called as a node. A loop is a closed path inside any electric circuit. See here, this is called as loop. This is the one more loop, starting at one point, ending at that point only, without any open path. It is called as a loop. A loop is a closed path inside the electrical circuit. This is about the some of the viva questions from the part A of the BEEE Lab. So all of you prepare these questions and make a note of it and prepare well. Then you will answer properly if you learn all these viva questions. In the next class, we will upload the one more video related to part B, experiments viva questions.